Good afternoon, ladies and gentlemen, previous judges, and honored guests. My name is Rawinun Udomponglukkana. Today, it's my pleasure to share my research on the TMPRSS6 Polymorphisms and the risk of iron deficiency anemia in school-age children. Well, we all know that anemia affects a child a lot, especially in their development, in cognition, in psychomotor, and in behavior. However, despite our effort in reducing anemia these years, we have to admit that about 14% of Thai children are having iron deficiency anemia, or simply we call IDA these days. And about 26% are still having iron depletion. Here, let's take a quick review on the iron cycle. The iron in our body is controlled by a hormone called hepcidin, which reduces iron absorption from the gastrointestinal tract and also iron release from the liver cells into the plasma. So, when we are having iron depletion or iron deficiency anemia, we are expecting a lower level of hepcidin. And this is enabled through a TMPRSS6 gene, which is short for transmembrane protease serine 6, which is a gene that encodes an enzyme called the matriptase-2 that cuts down the hepcidin transcription. So, when there is a mutation in this gene, hepcidin is not regulated, and there is an increased hepcidin level in the setting of iron deficiency anemia. And this causes a disease called iron refractory iron deficiency anemia, or we call it IRIDA, and the figure above shows the mapping of mutations found so far for the IRIDA disease. So with mutations in the TMPRSS6 gene causing a disease, single nucleotide polymorphisms, or SNPs, are roughly studied and have been associated with iron parameters. The one in your right upper corner, you can see, the RS855791 has been the most well-known SNP for the TMPRSS6, and it is found to be associated with lower hemoglobin, serum iron, transferrin saturation, and TIBC. So, our question is, if these TMPRSS are associated with the iron status in pediatric population. So we come up with two SNPs. The first one is the one I mentioned earlier, which is a C to T change. We simply call it the V736A. And the other one is the one most commonly found in Asia, which is an A to T change. We simply call it the K253E. So we did a cross-sectional study by recruiting children aged under 15 years from 4 schools, have their blood sample taken, and sent for CBC, iron study, genetic study, and hepcidin assay. So in genetic study, we simply do DNA extraction and polymerase chain reaction. And with the help of RFLP, we were able to distinguish between each genotypes. And the picture on your right lower corner is an example of the gel we did in the lab. The first one is read as TT, second one as CC, and the third one as TC, respectively. And to ensure that our reading is accurate, we also did a random Sanger sequencing of the samples. So after obtaining all the results, we are able to classify children into 3 groups, the IDA groups, the ID, and the normal groups. And when combined with the genetic results, we analyze it with ANOVA test and chi-square test. So here's the result. We are able to recruit 456 children, with the majority of them are girls, consisting of 64%. And the table below shows the demographic data. As you can see from the data, the people with IDA, there are significantly more female genders, and they are a little older than the other 2 groups. However, the BMI does not differ between the 3 groups. Also, here shows the iron parameters. As you can see, hemoglobin, ferritin, serum iron, transferrin saturation are significantly different between the 3 groups. This is as we expected. However, the hepcidin, even though the number is a little higher in the IDA group, it doesn't show any statistically significant difference. So we come to the box plot of serum iron and genotypes. The one on your left is for V736A, and the one on the right is for K253E. And from the two graphs and the yellow box, you can see that the TT genotype and the AA genotype both have significantly lower serum iron when compared to the other types. Okay, so however, the distribution of genotypes between the three groups are not statistically significant. So we further analyzed when we combine them together and make a lower iron group versus the normal group. So we are able to find that the AA genotype for the K253E has an increased risk of having low iron with the odds ratio of 1.76 and a p-value of 0.01. And we did further combination analysis when we combined the two SNPs together, and we found that the TT plus AA gives us an increased odds ratio of 1.97 with a p-value of less than 0.01. So in conclusion, our study found that the TMPRSS polymorphisms are associated with an increased risk for having ID or ID. So is it worthwhile to keep in mind that genetic testing is also an important tool when you're facing IDA without a known cause or IDA that is refractory to the treatment. And also, with the technology moving faster and cheaper and easier to access, it might be worthwhile that in the future we may be able to obtain these SNPs and get a personal advice on whether people would need to eat more iron to keep preventing them from having iron deficiency anemia. Thank you.
Let's move on to the question and answer session. Do the judges have any comments on the questions?
Okay, hello. Thank you for a very nice presentation. I'm wondering, since the iron deficiency anemia could be affected by many factors like maybe like gender, nutritional status, or socioeconomic status, or some of the children in your studying is reach puberty, which could potentially affect the iron status. I'm wondering, like, have you incorporated this into like adjust in the model for the outcome, or you just compare hemoglobin level between each group?
Okay. Thank you for the question. Actually, the odds ratio I show in the presentation is achieved by the multivariate analysis, considering the sex and age and so many factors together.
I see. That's a very important message. Yeah. Thank you.
Thank you.
Good afternoon. Great presentation and good statistic test. I'd like to add, I'm interested that you mentioned about iron deficiency anemia refractory to iron supplement. But do you have any data comparing the iron supplement dose between those with the mutation and those with the wild type gene?
Supplementation dose? You mean, okay. So in this study, we only recruit children, have their blood sample taken, and seeing whether they are at increased risk of having iron depletion or iron deficiency anemia. So we have not done intervention on them yet. So we don't have a recommended dose on whether they have the wild type or the mutated type yet.
Okay, I agree with that. So I think the conclusion sentence about you have to maybe about the iron refractory, iron deficiency anemia might be over-concluded, in my opinion.
Thank you.